All right, so we've talked about blockchain as digital money, right? But today, we're taking a huge leap forward. We're exploring its evolution into something much, much bigger. A fully programmable global computer. Welcome to the world of Blockchain 2.0.
So, we're all pretty comfortable with the idea that blockchains can work as a decentralized ledger for money. But the big question, the one that really kicked off this next era, was can a blockchain do more? Can it execute logic, enforce rules, and become, well, smart?
Okay, so to really get what a huge jump this was, we've got to look back for a second. What were the limits of the early blockchains, like Bitcoin? Why couldn't they just run any application we wanted them to?
You see, Bitcoin was brilliant because it was so focused. Its programming language, called script, was intentionally, super limited. Think of it this way. If the blockchain is a database, Bitcoin's language could only run one very, very specific query. Move this value from here to there. And that's it. It made it incredibly secure for payments, but you couldn't use it for anything else. It was basically a calculator, not a computer.
And then came the real game changer, a Turing-complete programming language, which is famously used by Ethereum. Now, I know that's a geeky computer science term, but all it really means is that the language can be used to solve any computable problem you can think of. Suddenly, as you can see here, the whole game changed. The blockchain went from being that simple calculator just for payments to a universal computer where developers could build, well, pretty much anything. So this new power, this ability to program anything, gave us the key tool of what we call Blockchain 2.0, and they're called smart contracts. But what in the world does that actually mean? The idea behind them is actually pretty simple, but it's also kind of profound. If we can trust code to securely handle digital money, what else could we program it to control? This is where we shift from just programmable money to the much bigger idea of programmable agreements.
Okay, so what is a smart contract? At its core, it's just a program, a piece of code that lives on the blockchain and automatically runs an agreement when certain conditions are met. Now, for anyone here with a database background, this is going to click right away. It's basically like a distributed, unstoppable database trigger or a stored procedure. It's just code that enforces rules automatically without needing a middleman.
And when you compare them to traditional contracts, it is a night and day difference, right? Traditional contracts are written in this ambiguous legalese, and they're enforced by courts and lawyers, which is slow and expensive. Smart contracts, they're written in precise code and enforced automatically by the entire network. Think about something like a trade finance deal. Instead of a bank holding money in escrow, a smart contract can just release the payment the instant a shipping container's GPS confirms it has arrived. You're literally replacing legal arguments with cryptographic proof.
All right, so we've got this awesome self-executing code, but a program needs a computer to run on, right? So where do these smart contracts actually execute?
Yeah, let's stick with that computer analogy for a second. If the smart contract is the software, then what's the hardware? Where does it actually run? The answer to this is what truly turns the blockchain into a global computer.
And this is it, the Ethereum Virtual Machine, or EVM. You can think of it as the runtime environment for all these smart contracts. Here's the crazy part. Every single computer, every node on the network, runs its own copy of the EVM. And together, they create this single, shared, and basically unstoppable world computer. To bring it back to our database analogy, the EVM is like a global execution engine that makes sure every single node gets the exact same result from a procedure call. That's how it keeps the whole system in sync. So let's walk through how this actually works. First, a developer writes their code and deploys it out onto the network. Then you, a user, send a transaction to that contract to make it do something, and this is where the magic happens. Every single node on the network processes that transaction on its own copy of the EVM. They all come to the exact same conclusion, which is then verified by consensus and locked into the blockchain forever. It is decentralized validation on a massive, massive scale. Okay, so we have smart contracts, and they're running on this giant global computer. The next logical question is, what can we actually build with all this? What do these new kinds of applications even look like?
Well, think about it. What happens when you take all that powerful back-end logic, the smart contracts, and you put a familiar user interface on top of it, like a website or a mobile app? You get something totally new, a decentralized application, or a DApp for short.
And these DApps, they're not just one kind of thing. They cover a huge range of possibilities. You have purely financial applications, building things like insurance or crowdfunding platforms without a central bank. Then you have semi-financial apps, which mix money with other stuff, like in peer-to-peer marketplaces. And then you have totally non-financial applications, things focused on governance, secure voting, or even supply chain management.
Okay, so all that theory is great, but what does this stuff look like out in the wild? Let's check out a few real-world examples to see what kinds of problems DApps are actually trying to solve.
So here's a cool one, Golem. Their idea is basically to create a decentralized marketplace for computing power. So if your computer is just sitting there idle, you can rent out its processing power to someone who needs it, like a scientist doing research or a 3D artist rendering a film. The smart contract handles the whole thing, creating this kind of global supercomputer out of everybody's spare parts. Or what about the basic attention token, or BAT? It's trying to completely fix digital advertising. Instead of companies harvesting all your data, you, the user, can opt in to see privacy-respecting ads. And here's the kicker. You get paid directly in tokens for your attention. The smart contract acts like a totally transparent accountant, automatically splitting the revenue between you, the website publisher, and the platform. The whole point is to cut out those shady middlemen who hoard all the data and the money.
And it's not just for super techie stuff either. A project called Etherisk is building automated flight insurance. Now get this, your flight gets delayed. Instead of filling out a mountain of paperwork and waiting weeks for a check, a smart contract is connected to a reliable flight data feed. It sees the delay and instantly sends the insurance payout right to your digital wallet. It's replacing bureaucracy with pure automation.
And all of this really brings us to the biggest question of all. This blockchain 2.0 tech gives us the power to turn almost any agreement we can imagine into unstoppable, self-enforcing code. So if we can start to rely on pure math and cryptography instead of traditional gatekeepers and intermediaries, what does that really mean for the future of trust itself? Now that is a question we're all going to see answered in the coming years. If you found this breakdown useful, you know what to do. Go ahead and hit that like button, share it with someone who might be interested, and of course subscribe for more deep dives. Thanks so much for watching.